All right, so today we'll do the last section on this particular unit on triangle similarity. Basically, with triangles, there are some shortcuts you can use to prove that two triangles are similar. With ordinary polygons of any number of sides, so far we know that you'd have to say that all the corresponding angles were congruent and all the corresponding sides are proportional. The corresponding angles have to be congruent. The corresponding sides have to be proportional. With triangles, there's some shortcuts to that. You don't have to do all of those things. We're going to learn those three shortcuts today. The first one is the angle-angle similarity postulate. You don't have to know, angle-angle similarity postulate. You can just call it angle-angle, and you can put the little similar sign at the end of it. So it's angle-angle similarity. If two angles in one triangle are congruent to two angles of another triangle, those triangles are going to be similar. And the reason for this is that once you have two pair of congruent angles, what has to happen with the third pair? The last pair has to be congruent. So you've got all three pairs of angles congruent. And with triangles, if all the angles are congruent, that's actually enough because it's going to make the sides proportional. We won't go into all of that, but I'm going to draw a little figure down here real quickly. So let's say that we had, let's make them right triangles just for fun. We'll say that that's a right angle. And this angle is going to be congruent to some angle over here. So that would be an example of angle-angle similarity. With triangles, you only need to prove that two pairs of angles are congruent. So that's a lot less than proving all three pairs of angles are congruent and all three pairs of sides are proportional. You just need two out of the three angles. It also turns out that you could do side-angle-side similarity. Now, we had side-angle-side earlier this year to prove triangles congruent. That's why it's important that on the abbreviation, you must write the similarity symbol. If you don't, you're talking about side-angle-side congruence, which is a completely different thing. Okay? So when you're writing your answers on those, if you're going to use the abbreviation, be sure to put the similar symbol at the end. This says if two sides of one triangle are proportional to two sides of another triangle and the included angles are congruent, then the triangles are similar. So as an example, let's say that we had a triangle that looked like this. And then another one that was smaller that looked like this. Let's say I know that this side is 3 and this side is 9 and this side is 5 and this side is 15, and I know these two angles are congruent. So we've got a pair of congruent angles, and we need the sides around those angles to be proportional. So we've got to check that. Is 5 to 3 equal to 15 to 9? Yes. So those two triangles are similar by side-angle-side similarity because the angle is in between the two sides. All right, and then the last one is side-side-side. It turns out with triangles, if all of the sides are proportional, the angles will take care of themselves. Yeah, it's pretty nice. So let's say that we had two triangles. And let's say that these sides are, I don't know, 6, 8, and 10. And these sides are 9, 12, and 15. Math department, the sweetest department in the school. Yes. I do. Okay, will do. Bye-bye. Mr. Jennings, that was your awaited call. So we just need to see, are these proportional or not? So I'll match up the biggest to the biggest, 10 to 15. What does that reduce to? 2 over 3. I'll do the smallest with the smallest. That's 6 to 9.
How do you reduce it to 2 over 3? Always divide by the same number.
Yeah, we divided both of them by 5.
Okay.
It's okay. And here, 6 to 9 reduces to 2 to 3. And then we'll check the medium-sized ones, 8 to 12. It's also 2 to 3. So these two triangles are similar by side, side, side similarity. And again, it's important because we already have a side, side, side for congruence that you add the similar symbol at the end. Without that, you're saying something other than what you're meaning to say. All right, let's go on to page 2. Morrissey, you okay? Travis, I'm just going to start throwing things during class to see if I can keep you awake. All right, so I will say this section on the tests is the one that students lose the most points on every year. It just is. I don't know if it's because it's harder or what the deal is. So there are 2 instructions on this. The first one is explain why the triangles are similar and then find the indicated segment. Occasionally I have students who decide, I'll find the segment first. Bad idea. Okay? Do them in the order that they're asked. Explain why the triangles are similar. And this is an example of a type. You'll have one almost exactly like this on the test. I'll guarantee it right now. You'll have one just like this. The thing you should do is, because the 2 triangles, one of them is JAS and the other one is JME, they overlap each other, right? Anytime you have overlapping triangles, the best thing to do is to take them apart. So triangle JAS looks like this. And we know that this side is 16 and this side is 10.
AS is 14.
I'm sorry?
I think gave us AS is 14.
Oh, okay, thank you. Thought you were saying one of the ones I'd already written was 14. I was like, what? And then for the big triangle, triangle JME, this is going to be 30, and this will be 25.
40. It's 40.
Oh, thank you. Some days I can add. I appreciate it. So notice, do we have all 3 sides for this big figure? No. It can't be side, side, side then, because we weren't given all 3 sides. Okay? So we only have 2 possibilities left, angle, angle, and side, angle, side. Well, look, we were given 2 sets of matching sides, right? So it's most likely going to be side, angle, sides. Let's check the sides. If I match biggest to biggest, and this is how you label them. If you just have numbers all over the place, maybe like, okay, that's nice. I don't know what it means. JA to JM is 16 to 40. Let's see, both of those are divisible by 8. And that's 2/5. And then JS over JE will be 10 over 25, which is also 2 to 5. So I know at this point that JA is to JM as JS is to JE. I have 2 pair of sides that are proportional. To prove that they're proportional, you should write the proportion. Then you're like, well, I can't do the last pair of sides because I don't know these are similar yet. But what angle do both of these triangles have in them? Angle J. Is it the same angle J in both of these? Yes. Angle J is congruent to angle J by the reflexive property. We haven't used that in a long time. So, triangle JAS is similar to triangle JME by what reason? Yeah, side angle side similarity. And now we're ready to find ME. Well, we already know that the ratio from little triangle to big triangle is 2 to 5. So what side matches up with ME in the other triangle? AS, which is 14. Well, let's see. That'd be 2ME is 70, so ME is 35. Again, there will be a problem almost exactly like this on your test. It'll be on probably 2 or 3 different homework assignments. This is going to be on there. Again, I don't think it's super hard. All right, let's do a couple more. So for this one, we want to eventually find the length of RY. Am I given, in the small triangle, how many sides am I given? Just one. So is it possible this is going to be side, side, side? No. Is it possible it's going to be side, angle, side? No, I only know one side. So it's got to be angle, angle. So I need to prove that 2 pair of angles are congruent. There's a couple of different ways that you can do that. I'll take a suggestion.
TRY and IRS.
And why are they congruent?
They're vertical angles, so they're congruent.
Yeah. Angle TRY. Sorry. I'm having trouble today. TRY is congruent to angle IRS because vertical angles are congruent. What else were we told here in the diagram? Yes?
That TY is parallel to IS.
Okay, so since TY is parallel to IS, what conclusion can we make then? If those two are parallel, what angles are going to be congruent?
Angle Y and angle I.
Yeah. Or you could have done angle T and angle S. Angle Y is congruent to angle I by,
The alternate interior.
yep, very good, by the alternate interior angles theorem. That stuff from first semester doesn't go away just because we've changed the calendar. Cole, is there some reason why you're not writing this down? So now I can say that triangle TRY is similar. Well, let me mark these angles. We said angle Y is congruent to angle I. When I name the second one, how do I have to name it if I name the first one TRY?
R.
Nope.
SR.
It'd be SRI. We got to match up the matching pieces. T didn't have any marks on it, nor did S. So those two go together. So that's by angle-angle similarity. And now I want to find the length of RY. I haven't found the similarity ratio yet. And when I haven't, I usually start with what I want to know. So RY, what does it match up with in the other triangle? RI, which is 24. Equals, well, I need to go back to the first triangle, so that's got to be 12. TR matches up with, yeah, SR, which is 18. Just to make the numbers a little nicer, I will always reduce if possible. That's going to be 2 to 3. So 3RY is equal to 48. Dividing, we get that RY is 16. Okay, any questions about that one? All right, then on the last one, again, we have overlapping triangles, and I can see from a couple people's paper that you're already drawing them separate. That's really good. So I've got the big triangle, KDR, that has a right angle at K, and this side is 12. And then I have the little triangle that also has a right angle, and I know this side is 6 and this side is 9.
Are AD and YA parallel?
I don't know. Are they?
Because they're both perpendicular to the same line.
Yep. We could do that. There's actually a shorter way to get the other pair of angles, but you're absolutely right. They are going to be parallel to one another. First of all, what pair of angles do we know are congruent already because of the markings? Okay.
DKY and AY.
Yeah, you can call this angle angle K because there's only one angle at K in the original, but don't call it angle Y because there's more than one angle with a vertex at a Y in the original. So we can say that angle K is congruent to angle AYR or RYA, doesn't matter. Because, why? It's not really given.
Right angles are congruent.
Yeah, because all right angles are congruent. It's practically given, but not quite. And then what else do you notice about these two triangles? Yeah, they have the same angle R in both of them. This angle R and this angle R are the same angle, aren't they? So again, angle R is congruent to angle R by the reflexive property. That happens a lot when you have overlapping triangles. So triangle KDR is similar to triangle YAR by
Angle.
similarity. Yeah, by angle similarity. Now we're looking for the length of KR. So again, I always start with what I'm looking for if I haven't already done the ratio. KR, that's the first letter and the last letter, matches up with YR, which is 9.
How does KR match up with? Oh, actually, no, never mind. I was looking at it as 1.
Gotcha. And then I've got to go back to my big triangle. So that's going to be 12, which was KD, which matches up with YA, is 6. Again, I'll always reduce these. That's 2 to 1. Cross multiply, and I get that KR is 18. Okay, any questions about that? All right. Your assignment today is in the book again, and then we will have a quiz on Wednesday. That quiz will be pretty similar to the worksheet that you had over the weekend.